reacting to an interview Richard Sutton gave at Varkesh Patel's podcast. I think it was a really, really good episode. I think Patel did a phenomenal job in challenging Sutton. I don't know whether he really believes in all the things he said or not, and that doesn't matter, but it was a very productive conversation simply because I think he challenged some of the fundamental assumptions underlying intelligence and the mind, and it really surfaced what this is all about. I think I consider Richard Sutton the most important intellectual of our time. He's by far the most underrated intellectual of our time, even though he got the Field Medal. But he has, in my opinion, Newton status, Aristotle status. Um, what von Neumann, whoever you want to pick, because he is, and he actually says it in the interview. I'm a classicist, and I think I agree with that. He is not just an AI researcher with some nice gadget that worked really well. Nothing wrong with that. Kudos to all the people out there who are doing phenomenal work and giving us great tools. But he's more of a thinker. Like, let's say I'm a trained economist, so I would call it like he's a von Hayek or Rothbard, or one of those really fundamental thinkers that lays out the lay of the land of the subject, in this case intelligence, and that's really the truth, the ground truth. Now, whether we follow that path or not, that's up to us. In economics, we obviously didn't follow the path of the Austrian economists, even though that's the only economics that actually matters as a science, not as a political tool. Paul Krugman would say, no, well, I succeeded. I was able to hijack the economy, use Keynesian bullshit as a pretext to enrich myself and my buddies and give myself a Nobel Prize and convince other politicians that it's actually a good thing to spend money, which, lo and behold, drives us towards spending ever more money. And the result is, well, just look at the US balance sheet, 40 trillion in debt, in my opinion, towards the abyss. But nevertheless, back to this particular episode, anyway, Sutton is the intellectual father of intelligence. And the reason he's, in my opinion, more important than maybe others in that field is just simply because he's helped foster some of the most interesting AI agents. AlphaGo Zero, Mu-Zero. Those are really, really important breakthroughs in intelligence. And even though DeepMind has gone way out of their way to advertise their success, I still don't think that we appreciate it enough. David Silver, the lead on AlphaGo Zero and Mu-Zero, he's famous in Silicon Valley, but nobody, like Sam Altman is everywhere, and his contribution to AI has been taking risk, but intellectually he's not even close to these people. Musk, I would say, is intellectually at par. His contributions in AI have been okay. Grok is a phenomenal success. I would consider Musk more of a large data center builder. That's his main skill, and maybe hiring the right talent. But nevertheless, let's get back to Sutton and the interview here. What's the main message? The main message is we want to have continuous learning agents that learn from experience. We spoke about this before. We discussed the essay, the area of experience that Sutton wrote with Silver. So this is nothing particularly new for us here. Listeners, regular listeners, hopefully have been exposed to these ideas. Links in the show notes, the essay and the interview. I think what's really interesting here to me is, let's talk about what are large language models? What does training mean? What's the paradigm of training versus the paradigm of learning from experience? Let's just talk about those two, let's say, forks in the road, and where do we think we might be getting as a community. This is not your own podcast. It's September 27, 2025. This is Krim Delco. For the year, we're up 15%. The market's up 13.5%. We're outperforming by 1.5%. So learning from experience versus training. Well, what exactly does that mean? So let's start with training. When we train a model, we take data. Let's just take the original GPT model, generally pre-trained transformer, which is based on the transformer architecture. So that's what we do here is we take the internet corpus of data, we crawl the internet, we get access to books and articles. More recently, let's say Grok is accessing things like X and Facebook obviously can access threads and so on and so forth. So you access text. Let's just stay with text. So you access text, you tokenize it, which is you store it in a vectorized form, and you also store it in a form that the architecture, the transformer architecture, can use to learn about relationships between those tokens. And the purpose is to eventually autoaggressively predict the next token. And that's the goal. And Sutton says that that is not reinforcement learning. That is not learning from experience. That is, the wrong fork in the road, according to Sutton. As good as the language models are, but language, he thinks that real intelligence has to be based on goals. And that is congruent with our idea that, I don't know if it's actually related to Sutton or not, but we've spoken about this before. And there's an essay coming up actually where we talk about what could be the demand for intelligence. Like, is intelligence the kind of service that has unlimited demand, or is it the kind of service that how is it bound? And we argue in the essay it's bound by goals, because if you look at the actual quantitative definition of intelligence, which we use Marcus Hütter and Legg papers in the show notes. There's an easier way to formulate this, which is John McCarthy's definition. Intelligence is the computational part of an agent pursuing goals. So the computational part of that problem, like when you have an agent pursuing goals, there's a computational part, and that is what intelligence is. So it's driven by goals. Goals are the actual driving force. So, and what we argue in the essay is that the ability to actually formulate goals, pursue them, that's going to be what intelligence is eventually bound with. And that's in line with David Deutsch, with Karl Popper, that we are a constantly evolving species that has the ability to create our own problems, solve them, and then formulate new problems and solve them. And that is really what we humans are, as opposed to animals that do the same thing, but in a much slower, at a much slower pace. I mean, I wouldn't say that beavers don't solve problems, or squirrels or whales and so on and so forth, but we just have this ability to abstract away, and this goes back into deep philosophy. Deutsch, like, we can explain the seen with the unseen. So we can abstract away from our everyday, day-to-day life and experience, and learn and think about in abstract ways about the world, and come up with new things. And then as soon as we come up with new things, we create new problems, and then we have to solve those. So this is what intelligence really is all about. It's the ability to pursue goals. And I think that's very much in line with Sutton. And the reason he thinks large language models are on the wrong path of this trajectory is because they don't really pursue goals. And, Patel was challenging him on that. He said, well, they do pursue goals, predict the next token. And Sutton said, yeah, but if they predict the next token, all they do is come up with a good prediction, and they really don't have a lot of impact on the real world. And most importantly, they don't change based on what they do, because that's the key. The key of learning is a constant interaction between the agent and the ground truth, which is nature. And that's what learning through experience means. Now, my opinion, the way we see this is that eventually those two will converge. And the reason we think that is that we don't have continuously learning agents right now. There's a couple of engineering problems, and in my opinion, also cybersecurity problems. For example, if we had a Tesla that is driving and continuously learning while it's driving, I mean, how do you make sure the driving that it's learning on is a good driving? You know, you could have bad actors uh, forcefully, you know, force it to learn things that are not good. Now, Sutton might say, no, that's not the case. If we formulate the right goals, the agent will learn how to pursue goals. So, for example, if the goal is to, let's say the goal is in the Tesla case, the FSD case, which is the first real world AI system at scale that we're actually exposed to, uh, it is, you know, get me from A to B at low cost with a best possible user experience. So, you know, we're using the sort of the Jeff Bezos argument when he wrote in his shareholder letters, I can't really predict the future, but one thing I can predict is that people will always want low prices, high selection, and fast delivery, something like that, right? Or when it comes to running my company, I think I want to just produce free cash flow. That's a good goal to pursue. So if we can find goals like that, and in the case of the car, if you take, you know, so get me from A to B. I mean, it's a transportation problem first and foremost, and it has to be at low cost, and it has to be, you know, with a good user experience. So, you know, it's kind of hard to train this thing to do bad things, right? It has to do at low cost. It has to figure out ways to, let's say, get the shortest trajectory. The good user experience, okay, you can argue that's kind of a wishy-washy goal, but we can define that goal with a reward, and the reward would be more people start using the app because it's a good experience, and that's the reward. And the more people use it, the more reward you get. So the model starts maximizing for more usage, and that becomes a flywheel. So we could have, in principle, a system like that, but that's still an engineering problem because we have to deal with things like catastrophic forgetting and things like that. And that's partly the reason, because we have these hybrid systems now where we have pre-trained models that have weights, and then we continuously learn on top of them, and then we want to make sure they don't forget. And I would say the industry is actually pretty good at solving some of the problems. If you take, for example, Grok, Grok is able to, at this point, get you almost, I would say, close to real-time information. You can ask it things, what happened this morning? Why are people upset at Trump? It can give you decent answers. So it's able to build on its training corps, which it has been trained probably with data up to 2024. But it is able to access tools and access, you know, maybe real-time information, read all the most recent X posts, and get you a bit of a real-time, you know, answer. It's not that great, but at least it can do it. So there is this, and then you could, you know, if you're Sutton, you could say, well, yeah, but what kind of real-world impact does this have? Well, you could have a real-world impact if you measured its response based on how people behave after they read it, and if you were able to actually get, you know, let's say here's the canonical example. Maybe that's an easier example. So you're looking for a coffee shop in Tahoe City. You ask Grok. Grok gives you the wrong, you know, it gives you, which happened to us yesterday, it gives you the name of a, actually it wasn't Grok, it was Google, sorry. Google gives you the name of a coffee shop. The coffee shop is closed. And now you could say, well, that, you know, what can you do? It's like it's been trained on data from the past, and it hasn't been updated, and blah, blah, blah. And the next batch, it will be updated. So it is what it is. We're just not a real-time system. But Sutton would say, why should it be like that? How about you connect the recommendation engine, in this case, the Google search engine, with the phone of the person, and you test whether they actually bought coffee in that coffee shop, maybe within an hour of the search. And if more people do the search, and then you find out that nobody's actually ends up buying, you start changing your recommendation to something else, because you realize nobody's buying. There's something wrong. You don't even have to know what's wrong. Are they closed? Are they on vacation? It's a bad recommendation. So what Sutton is trying to get through, I think, to us here is we have to have an agent that reacts through the environment and changes its behavior, and also changes the behavior of the environment. So that's kind of the world Sutton lives in. I think, again, he's been the intellectual father of AlphaGo, AlphaGo Zero, and MuZero, which are, in my opinion, still the most effective examples of how a real-world AI can look in the future. I think today we are exposed to, I would say, we're still sort of living in two worlds here. One is the classical intellectual world of intelligence, of which Sutton is the most prominent proponent today. And then we have the engineering real world situation where people are just working on systems, people are working on problems, and they are sometimes we have to do shortcuts, and we just have to make these things work. And but I would say that particularly going forward with humanoid robots, for example, we could morph into a system like that, which I used to call it the Robinson Crusoe robot. I think that's actually a phrase I borrowed from Sergey Levin, the Berkeley professor. A robot that not just pursues goals, but even has the ability to formulate its own goals. That is the holy grail. That's where we're going. That's where I think we can really increase our cadence of intelligence generation, and we can become a much more intelligence-driven society with intelligent agents that are based on the ability to pursue goals. And if we could train the agents to also formulate their own goals and then pursue them, I think that would be fantastic. So what that means is we have a goal formulation which then actively changes the algorithm, for example, the constraints that are necessary to train the algorithm based on the new goals. So there's a little bit of a almost a recursive element here, and I think it's a real interesting academic, intellectual, and engineering challenge that Sutton is putting us on, and that's I think what classical thinkers are really mostly doing, which is really give us the inspiration to think bold and fast and really beyond our current horizon, and then see what we can do with those ideas and implement them. Thank you.